All right, this next section that we're going to talk about in chapter 2 and 9, I guess, deals with naming ionic compounds. And obviously, we've taken a quick little look at how these substances get put together, how we balance the charges. I can't stress enough that when you put an ionic compound together, what you're doing is balancing charges. You're taking a charge of positives and a charge of negatives and making them equal, least common multiple, however you want to think about it, making sure that you are balancing charges. There's no addition, subtraction, etc. So let's take a look at naming them. The first, for binary ionic compounds. Binary ionic compounds means that you're talking about just two things, a positive and a one negative. There might be more than one of them, but one positive and one negative. When you name binary ionic compounds, the cation is always named first, and its name is the same as the element name. The cation is always named first, and its name is the same as the element name. And then you have a monatomic anion. You drop the ending, and you add the suffix "ide." So again, if we take a look at an example, let's say we have aluminum getting together with oxygen. Okay, let me move this. All right, aluminum with oxygen. So you look on the periodic table, aluminum's number 13. It has a 3+ charge. Oxygen is number 8. It has a 2 negative charge when it forms an ion. So we've got our 3+, our 2-, which of course the least common multiple is 6. We would need 2 aluminums, okay, and we would need 3 oxygens to balance the charges, to make the positives and the negatives cancel out. Right? We got 6+, 6- if we do it this way. So there is your formula for aluminum when it gets together with oxygen. Now to name it, the cation is always the name first, and its name is the same as the element name. So we would just name this aluminum. Okay. We have a monatomic anion. What I mean by monatomic, one atom, mono or monatomic anion. Now we do have 3 aluminums, big deal. We drop the ending and add the suffix. So we drop the -ine, I guess you want to say, and we have oxide. Notice the oxide. And again, I wish I could say how many letters you drop or what part you drop, but basically that's what it is. You drop the ending and add the "ide." You'll see how simple it is. We don't have to say a darn thing about the fact that there are 2 or 3, because when aluminum and oxygen get together, it's always going to be aluminum as a 3+, oxygen's always a 2-. There's no other way for it to get together other than aluminum with 2 and 3 oxygens. So that's aluminum oxide. Okay, let's do another one. Calcium with fluorine. Okay, calcium, you look at it on the periodic table, it's number 20. It has a 2+ charge when it forms its ion. Fluorine is number 9. It has a 1- charge. So you've got your 2+, your 1-, the least common is 2. We need 2 fluorines and 1 calcium to get our correct formula. Okay, when we're putting the ionic compounds together, the formula, okay, we're balancing the charges. Again, you can think of it however you want to. I like thinking, 2+ charge. Here we have 2 fluorines, each at a -1. That gives me a 2-, which will cancel out that 2+. So CaF2. Now to name it, calcium. Why? Because the cation is named first, and it's the same as the element name. And then fluor, and instead of fluorine, we're going to drop the ending and add IDE. So there's calcium fluoride. All right. If I now would say, all right, let me give you the formula of something. So basically what I was saying and what we've been just looking at is if you put a couple together, oxygen, aluminum, whatever. But what happens if I give you the name of something and ask for the formula? So let's say I gave you magnesium nitride. Magnesium nitride. Well, again, the magnesium describes that it's a cation. It's listed first. To know the formula, to be able to write the formula, we're going to do magnesium. Look it up on the periodic table. It's number 12. It has a 2+ charge. And then nitride. Well, the nitride must be the nitrogen. We've just dropped the ending and add the -gen and added IDE. So that's the nitrogen. We look up nitrogen, number 7 on the periodic table, which is a 3+. 2+, 3-, least common of course is 6. The formula would be Mg3N2. You could do the crisscross method, or you could just say least common. So there's the formula. Again, coming from the formula to the name, if I were to just say, all right, let's have Li3P. Li3P. This is obviously lithium with its +1 charge. Phosphorus has a 3-. If you look at them, lithium's number 3. It has a 1. It's on the far left. It has a 1+ charge. Phosphorus is number 15. It has a 3- charge. That's why you need 3 lithiums to take care of that 3-. The name, lithium, just lithium, phosphide. We drop the phosphorus, we drop the oris and add "ide." So again, it's lithium phosphide. I don't say a darn thing about the 3. I don't have to say there's trilithium. It's just straight lithium phosphide, because lithium was always a 1+. With phosphorus, which is always a 3-, you always will have that. Okay, so there's binary ionic compounds. If I now take a look at moving a little bit further here, and take a look at transition metals. And we'll come back to that in the next section.